Every routing protocol has got something special. ISIS is also one of the special routing protocol. ISIS stands for intermediate system to intermediate system. It is nothing but router. Intermediate system means router. This is a routing protocol running between routers, right? Routing protocol runs between routers. So early days, the name given to the router is intermediate system because they are in the middle. Sender is here, receiver is somewhere here. So these devices are called as intermediate systems. So they named it as intermediate system to intermediate system protocol because it is working in between the sender and the receiver, because it is working on the router. This is for routers to learn routes. Intermediate system to intermediate system. Use of ISIS routing protocol. It is really used in large ISPs. I have seen big ISPs. They use ISIS as a very stable routing protocol. And this routing protocol, ISIS, originally developed by ISPs because the government, US, was insisting to have a routing protocol that will support IP and OSI. Please understand, ISIS was not a protocol of IP in the beginning days. It was not a protocol of IP. It was supporting a protocol, old protocol called CLNS. Like IP, in olden days we had CLNS. So ISIS was supporting only CLNS, but that CLNS was not OSI standard. That CLNS don't fit much, into the standard of OSI. So government was insisting to have a routing protocol that will match with the rules and regulations of OSI, and that also will support IP. So what they did is they did some modification to the original ISIS so that it will fit into OSI, and it will also support IP. Earlier, the ISIS was not fitting into OSI rules and regulations, OSI model. So the ISIS routing protocol that we are learning now is a altered version of, it's not the original version, it's the alteration done to match the OSI and the IP. As I said earlier, IS means router. Router to router was originally designed as an IGP for the protocol called Connectionless Network Service, CLNS, which later became a part of OSI also. And now the OSI protocol suite layer 3 protocol is CLNS. So what I was telling is CLNS is equal to IP today. What layer protocol is IP? Layer 3. Which layer IP works in OSI? Layer 3. In layer 3, network layer. Correct. So it's the same layer where you also have CLNS, Connectionless Network Service Protocol, CLNP. CLNS is what called as CLNP, the protocol. So ISIS now, sorry, earlier it was using CLNS as a layer 3 protocol. So the router ID of that ISIS is different from the IP address. So ISIS uses CLNS addresses to identify a route and to build LSDP. What does LSDP stands for?
Link state
Yeah,
database.
very correct. Link state database. So OSPF is also building link state database. But OSPF uses a 32-bit IP address format as a router ID. Correct, no? OSPF will use a router ID which looks like an IP address, isn't it? But
It is.
ISIS uses CLNS address even today. For identifying a router, ISIS is using CLNS address. When you configure, we will be configuring net address. What does that mean? It's a CLNS address, not the router ID. We don't have a 32-bit address format for CLNS. So CLNS address is totally different, which we will be learning in coming slides. So what we have seen so far, IS means router. So this is a router to router routing protocol. Originally it was developed to support the CLNS protocol, which works in layer 3, but later the pressure was given from the US government to alter it to design to support IP. So the one which we are learning now is the IP version of ISIS. But the router ID is still the CLNS address. Only the router ID. But for communication, it will use what? IP address. But the router ID is still CLNS. Now, some features of ISIS. ISIS is also a link state routing protocol like OSPF. ISIS also supports variable length subnet mask. ISIS also uses Dijkstra's algorithm called shortest path first algorithm.
It's like I'm not hearing anything.
So because there was an audio issue, I'm redoing it. ISIS is also a link state routing protocol like OSPF. Both ISIS and OSPF supports variable length subnet mask. Both ISIS and OSPF uses the same algorithm called Dijkstra's algorithm, which is also called as shortest path first algorithm. Or there are many names like binary tree algorithm. That also means SPF algorithm. Now, because they use a link state routing protocol, they maintain a database of the complete topology. As a result, they can guarantee a fast convergence. See, when I have a map in my car or in my bike, when I have a map, if one road is blocked, I can immediately look into the map and take next diversion. I can take next alternate route. But if I don't have a map, then problem. I need to ask someone for the new path. That will take a lot of time for us to know the new path and then keep moving in the new path, asking many people in the way. That won't be practically possible in grown-up cities in first place. you need to have a navigator.
That's true.
So for fast convergence, when you have the complete map of the topology, if one path goes down, immediately you can switch to another path. In that way, ISIS is fast in convergence because ISIS also maintains the database, the link state database like OSPF. Next, like OSPF, ISIS also sends hello packets in order to establish adjacency, meaning to discover neighbor. See, someone is sitting in the airport and you are also sitting in the airport for a long time and you are feeling bored. What do? You just go and say hello. And he also will say hello. Then only the neighborship starts. When you say hello, if you don't say hello back, you won't be comfortable talking to him anymore. Yeah. So neighborship cannot be established. So neighborship begins by saying hello. Likewise, in ISIS, the routers will start saying hello. If one router can listen to the other hello, so the other router can be discovered. So they keep exchanging the hello packets. That helps to discover neighbor. After neighbor is discovered, there is a link state PDA. This is same like link state advertisement. In OSPF we call LSA. Here they call it as link state packet data unit PDA. LSA. This is LSP. P means PDA, packet data unit. It is nothing but packet, LSA packets. So they exchange what? Link state advertisements. That is what here it means. Link state packet to exchange. That is how they learn each other. See, only the terminologies will differ. Instead of LSA, you say LSPDU, not PDA, PDU, packet description, packet data unit, LSP. This P stands for packet data unit. Right? In a simple word, it is packet. That's all. No need to say packet data unit. It is packet which is exchanging the link state information as an advertisement. So once you say hello, what is next? You need to exchange the updates. You need to exchange the link state updates. That is what exchanged in the form of LSP. Now, ISIS uses bandwidth, memory, and processor effectively. What does that mean? ISIS will not calculate the metric based on bandwidth. Let me repeat. ISIS will not calculate the metric based on bandwidth. In fact, there is no auto calculation of metric. ISIS, see, if it is OSPF, it will check the bandwidth and calculate the cost. When I have in OSPF 10 meg wire and 100 meg wire, the cost for this will be 1 OSPF cost. The cost for this will be 10, isn't it? When we go to OSPF, I'll explain this in detail. So OSPF will automatically calculate the cost depending on the bandwidth. ISIS will not do that. ISIS, no auto calculation. We only need to provide the metric manually. If you don't provide metric manually, every single link is considered as, every single link will be considered as 10 metric. Every single link metric will be considered as 10. For example, the cost to reach between A and B will be 10 plus 10 plus 10 plus 10, 40. If you have gig Ethernet, if you have fast Ethernet, even then, this is also 10, this is also 10, this is also 10. What does it mean? ISIS will not care about bandwidth. There is a fixed cost. For each link it is 10, but you can go manually change the cost. If I have multiple paths, if I have another path, and when you prefer to go via path 2, you can give cost as 5 and 5 here manually. So that if I go this way now, 10 plus 5, 15 plus 5, 20 plus 10, 30. 30 is the cost, whereas the upper path is 40. Yeah, here we have manually specified. So it gives you the flexibility of deciding the path manually by setting the cost. There is no auto cost. By default, the link cost is 10. Anyway, there is no connection between the metric and the bandwidth here. That is what I want to say. Metric and bandwidth has nothing to do. We can see which path has got better bandwidth, and we can go and provide low metric. In that way, we can efficiently use the available bandwidth. And we can also do load sharing between the path. For some destination, the metric via path 2 will be less. For other, the metric via path 1 will be less. In that way, you can share the load so that the process and memory and bandwidth can be shared, efficiently used. Now, this ISIS routing protocol also have got hierarchical design. Like OSPF having hierarchy design. OSPF has got two-tier architecture, right? In OSPF, we'll have area 0 and the non-backbone area connected via a ABR. This is an ABR. Internal routers of area 1 and area 2. What I'm coming to say here is, when you have multiple areas connected to one backbone area, all areas can communicate to other area via area 0. That is how OSPF is designed for scalability. How it is more scalable? Because you got multiple areas, you can do summarization on the border. Anyway, we'll not talk about OSPF. Now, what I'm coming to say is, same like OSPF, we also have areas in ISIS. Same like OSPF, we have two hierarchy level. One is L2, another one is L1. But the big difference is, here in OSPF, you have some router as a border router between the areas in OSPF. Whereas in ISIS, you will not have any router as a border. In ISIS, this is one area, This is totally another area. This is another area. And the router here and the router here. They are connected, but not like this. In OSPF, it is like this. One link will be in area 2. Same router, another link will be in area 0 in OSPF. In ISIS, that is not allowed.
They are independent.
They are totally immersed in one area. A router cannot be a member of two areas in ISIS. How and why? You see, this port, let me say F01, belong to, let's say this is area 10. Any area can be a backbone. There is no fixed number. Here area 500. Here area 1. So now if you see on area 10, this F01 belong to which area? Area 10. This port, let's say F0/0, this belong to which area? Area 500. They can form neighbor. In ISIS, the neighborship is possible. In OSPF, they cannot form neighbor if they belong to a different area. If these two routers in OSPF R1 and R2, if you expect them to form neighbor, this port and this port should be in same area. Otherwise, they cannot form neighbor. They must be in same area. That is why we have ABRs. That's why we have ABR. If you see ABR, sorry. This is area 0. Now, this port and this port, they are in same area 0. Likewise, this port and this port belong to same area 1. They form neighbor. That is how the ABR is formed. Whereas in ISIS, this is not allowed. You cannot have one single router in multiple areas. You cannot have. So you cannot have multiple areas on the same router. Then how the neighborship is allowed when they are in different area? In ISIS, area ID doesn't need to match. Whereas in OSPF, they should match. In ISIS, this is not a criteria. Area ID is not a criteria. In order to form neighbor, they need not to be in same area. The ports can be in different area. The hello packets that is coming, no, they can be from different area. Yep. So between two different areas, hello packets are coming from different area IDs. Then what should match? What is necessary to form neighborship? In OSPF, area ID is mandatory to form neighbor. Area ID should match. In ISIS, they need to be L2. If you have a L2 router, what is L2? L2 is one of the ISIS neighborship type. Like in BGP, we have IBGP,
EB.
EBGP, right? This L2 is like EBGP.
Okay.
Without EBGP, can you form neighbor with two different autonomous systems? No possible.
No.
Likewise, without L2, routers in two different two different areas cannot form neighbor. L2 relationship is what important to exchange the prefix information between areas. Now, this line is more meaningful for us. You see now, we understand this line.
Okay.
Between areas, the prefixes informations are exchanged as L2. So this is two different area, but what relationship you have is L2. They can exchange the route. They can form neighbor. They can exchange the route. Whereas L1 is local area. It is like an IBGP. Only a member of same area can form neighbor and exchange route if it is L1. If it is L1, member of same area only can exchange routes. Fine. We will be learning more about L1 and L2. As of now, one important difference is in order to form neighbor between two different area members, you need L2. Now, on Cisco routers, when I enable ISIS on a router, even if it is in same between two routers in an area, if I form ISIS neighbor between two routers in an area, let's say this is area 500. Even though it is same area, both L1 and L2, two separate neighbor will be established. You understand? In Cisco devices, whenever you enable ISIS on router, two type of adjacency is formed. One is L1 adjacency, other one is L2 adjacency. But do we need an L2 adjacency here? Same area?
No.
Not necessary. So you can go inside and suppress. You can go inside and say, I don't want L2. So that you can save some processor. You can reduce the process utilization. Otherwise, there will be double the amount of CPU. By default, whenever you enable ISIS, there will be two adjacency, L1 and L2. Between different areas, I really don't want what? L1. So only L2 you can keep here. Likewise, you cut L2 here, only L1 you keep here. In that way, you can reduce the utilization of CPU and memory. But by default, everywhere you will see both L1 neighbor separate, L2 neighbor separate. L1 and L2 separate. we have to manually go and disable the one which you really don't want there. Yeah. Now let us go to the next page.
Please, can I ask a question?
Please, anytime you can ask question.
Okay. Yeah, with respect to the same area,
Yes.
how do you know that this is what should I call L2 or L1 within the same area?
Okay, you need to type show ISI's adjacency,
Yeah.
show ISI's neighbor. It will show you two.
Yeah. Okay.
And we go to the ISIS router mode and we say ISIS type level
Okay.
on only. There is a
Okay.
command level 1 only. No?
Okay.
Let me quickly show you. There may be some configuration in this page. Sorry, not in this chapter, next chapter. The configuration
No
will come in the
problem.
next chapter.
It's all right.
Okay, so what we learned. Intermediate system is a very good, highly scalable service provider routing protocol. But surprisingly, I have seen some enterprises also using it because this is very scalable, highly scalable, lightweighted protocol. I like ISAs more than OSPF.
Okay.
You may also like it after the class,
Okay.
ISIS class. Now, this ISIS, intermediate system to intermediate system, originally was designed for another layer 3 protocol called CLNS. Later, it is modified to support IP. Now, like OSPF, a lot of similarities like link state routing protocol, support for VLSM, same Dijkstra algorithm, SPF algorithm for the shortest path first. And then because it maintains the database, the link state database, the convergence is very fast compared to other distance vector protocols. This also sends hello packets to establish neighbor, but in the hello, the area ID doesn't need to match. In OSPF, area ID should match to form neighbor. Here, that doesn't need to match. And then this effectively use the bandwidth and memory and processor because there is no auto bandwidth configuration. Sorry, auto cost calculation based on bandwidth. No auto cost calculation like OSPF. And now ISIS also follows the hierarchy design like OSPF, but the difference is here there is no ABR. Two routers in different area can form neighbor if they are L2 adjacency. If it is L1 adjacency, the neighbor should be within the same area. Wherever you don't want L2, you can suppress L2. Wherever you want L1 only. See here, this blue router, if you notice here, it is L1 only. They suppress the L2 in this link, but L2 is here. They can suppress L1 here, but if they suppress L1 here, then they cannot have L1 here. That's why they keep L1 there. Anyway, this L1 and this L1 will form neighbor. This L2 and this L2 will form neighbor. So this router should run both because it is talking to other area also. But this router is not talking to any area. It is local. That's why it is L1 only. This too only L2 because it only talks to other area. It is not talking to any local router. That's why there is no L1. L1 is needed if you have local area members. Yeah. So with this we'll stop. We'll continue again from the same page where we leave today in our next class.